never know for sure. If somebody could validate that in the chat, that would be great. But it's my third week live streaming in a row, so hopefully I've got the hang of it now. I am back in the Friday Lambda Lab with some new things to record. Um, so a couple of things that are on my agenda today. I've got two kind of that I definitely want to do, and then I've got a bunch of other stuff that I don't know. We'll see what I get to. So the two that I definitely want to do. One is I was playing Harry Gross's Not in Kansas Anymore last night, and um, there was a question in it about, if you take a certain number of hex steps from a place, where can you get to in n steps? And 3 steps, I think, was the question. Anyway, I remember doing it on the live, or no, not on the live stream, but live on the day, and I took my set of directions, like here are the 6 hex steps that you can take in my RCref form, and then you could just like these are all the places you can get to in 1 step. You add all the directions. Those are all the places you can get to in 2 steps, and so on. That's just a handy. I think it'll be a pretty simple one, but that's a handy one to have. Second one is Unsplit. This is inspired by J.J. Cifuentes, the original creator and comer up with of the excellent name. But this is like a split and I don't think it really does unpivot, but anyway, a split and extend to tape. So the idea is that you have a set of data like this, where you have a mix of label columns and list columns, and what you want to do is split each of those. So the idea being that each of the list columns is the same size. So like here's a list of 4 things and a list of 4 things, and so what you want to do is split each of the lists by row, same as the like Power Query split by row function. And repeat the labels so that you would have 4 rows that say R45 M102, then R64 M19, then R163 M53, and so on. And JJ has a nice implementation of this using the by row and by col functions that I've mentioned before, the sort of generalizations of the native one spelled with a Y, by row and by col, that can return arrays. But his one involves 2 calls to, I think it's like 1 call to by row to operate on each row, and then a separate call to by col to operate on each element here. And I think that there's, not without any compromises, but I think there's a nice way to make it work with just 1 by row call and then some nice broadcast operations on each row. So that's that. And then some or all of these, depending on how we're doing for time. Line of sight, just, if you can look in, north, south, east, west, what are the things you can see, or if you can look in 8 directions or hex directions or whatever. Then time, or not necessarily time, could be date either, but like range functions. So things like, if I have from 1 to 3 and from 5 to 7 and from 2 to 8 or something, then, the union of these is from 1 to 8. Or the intersection of this set of ranges with some other set of ranges. This is the thing that made me think about this was the question in the Brazilian competition about service level agreements, where it was things like, one service is out of operation from 1 p.m. to 2 p.m. and another service is out of operation from 1:30 p.m. to 2:30 p.m. and you had to figure out the times that any service was out of operation, or equally it could, in principle, it could be times that both services are out of operation. So that one's kind of complicated. We'll see how, sorry, that one is kind of complicated. We'll see how I'm doing for time. Then I've been using byrow and bycol a lot lately. As there's a couple of generalizations I'm thinking about making to those. One is just a map equivalent so that you can give it an array rather than just operating on a row or a column, that it could also operate by element. And the other is to potentially make them multi-argument so that, you might be able to say, I want to operate on each row of this and also on each row of this, separate vector over here. So you'd have a function that applied to one element here and a row here, or, one element here and another element over there, or whatever. And Traveling Salesman keeps going to the bottom of my list. And then Bellman Ford, I'll explain that when I get to it. All right, so enough yak. Let's talk about n steps, shell, and ball. So start off with something simple. Let's just do up, down, left, right. So take my arrow offset code. Oops, sorry, arrow offset codes. So this is all kind of as before in the language of my row column offset codes. I say my, more Bo's row column offset codes that I have aggressively embraced. So the idea is that, upper row is -1,000,000, down row is +1,000,000, left and right is ±1. Left is negative, right is positive. So in other words, these are the 8 sort of cardinal compass directions in row column reference form. So for now, we're just going to operate on the 4, which is up, down, left, right. So these are, relative to a given starting point, these are the places you can get to in one step. So where are the places you can get to in 2 steps? Well, you can H stack 0 with 2 row of this. So you can either, stay where you are because these are already places you can get to, or you can go on in any of these directions, and then you can say this plus this. These are all the places that you can get to in up to 2 steps, and then you can flatten that and take the unique of that, and maybe even sort it if you're feeling fancy. And those are the places that you can get to in 2 steps. And of those, this one, this one, this one, and this one are places you can get to in 1 step. This is obviously 0 steps, and all the rest are places that you can only get to in 2 steps. So, I think what I want is, I want a number of steps, obviously. And we'll start off with that being 1, keep it simple. Then I want my set of directions, and for now we'll just make that this. Actually, sorry, let's make it just so Robot does not get confused into thinking I want a downstream reference. Okay, so then we're just going to reduce starting from 0. Starting from H stack 0 and 0. So the idea is I want to be able to say this is where I can get to, and this is the number of steps at a minimum that it takes me to get there. So then I want to reduce sequence of number of steps, lambda a v. Then just trying to think. That doesn't matter. Doesn't matter. So we're going to say trying to decide how verbose I want to be. Let's be verbose. Let's say let let's say let last be filter take a first column where take a last column equals v minus 1. And then let's just return LSD for a second. Okay, so in other words, we start off saying we can get to 0 in 0 steps, but then later we'll say we can get to 0 in 0 steps, or any of these places in 1 step, or etc., etc., etc. So I just want to get what are the places I could get to on the last step, because I don't need to add to anything else. So then it's going to be last plus H stack. I guess I don't need to apply 0, so we'll just forget the H stack. 2 row of this, of my dears. So then it's going to be unique to call of that. So that gets me 1 step. Then I want to expand that to 2 columns pad width v. So that'll say these are the places I can get to in 1 step. And then, so this can be nxt for next. Let's just spread this out a little more. So that's last, this is next. Then then I guess I want to v-stack a with filter nxt where is error. And so basically I want to say, if any of these, like in 1 step, you can only go out to the 4 places, but from those 4 places, you can take steps that would get you back to where you started, like back to 0 steps, or that would take you on to new places. So I want to filter out anything that has already come up before. So we're going to say, is there X match nxt, take nxt first column against take A first column. So that's the take, that's the X match, that's the is error, that's the filter, that's the VStack. Okay, that looks promising. Then we go 2 steps. Now we should have 8. Yes, 8 more places we can get. Let's go 3 steps. And then we should have 12, I think. Yes, 12 places we can get to in 3 steps that we can't get to in less than that. Okay, so then we're going to say let, so what term did I use here? I used ball and shell. Yeah, so the idea being that, you know, like over here, it's probably easier to think of it just this way. So if it's, you know, that's where you can get to in 1 step, and this, whatever, is where you can get to in 2 steps, and this is where you can get to in 3 steps, then I might be interested, you know, if I say, oh, sorry, that's 2 steps, not 3 steps, but if I say 2 steps, I might be interested just in the green, the outer shell, or I might be interested in the whole ball. Am I going to be interested? I don't think I'm going to be interested in the number of steps as an output. I don't know. It's conceivable that I will at some point be interested in that, but I'm going to say for now I'm not. So, let I'll call it up to n be that big reduce. Oh, sorry, wait. So I need another input, which is I guess last only, and that will be I guess. No, what about, yeah, I want my default to be return everything that you can get to. So yes, last only is the right way around because you have to proactively put something in. Good. So then we're going to say let, what on earth did I call this? Up to n, yes. Be that reduce, then if last only, sorry, not last only, just pointed here. Robot will take care of that stuff for me. If that, then filter up to n, sorry, filter take up to n, first column where take up to n, last column equals max of take up to n. This pattern almost feels like it should be a lambda in itself, like it's so simple, but it's also so frequently used. But anyway, fine. For now, so that is my just the ball, and then otherwise I just want to take up to n, first column. Okay, so that gives me everything, and then last only gives me just the places that it takes 3 steps to get to. I think that's basically what I want. So we'll call this, what will we call this? I guess steps. I don't know, what names have I already got? I don't have anything that looks like steps. In my head, this is either n steps or it's steps. I think steps is easier. So I'm going to go with steps, and then let's try save lambda as. Okay, so we got num steps, directions, last only. That I want to be optional. Okay. Then up to n is all that. Yeah, that looks perfect. I say okay. Go underscore steps. Save. Cool. And then let's just try if my directions are Kansas directions. So you can go 2 to the left, 2 to the right, or you can go drop our offset codes 4, or you can go up, down, left, right. So if those are my directions, then steps. Ooh, that does pick up our step. Maybe I should have gone. I don't know. I'll think about the name later. Steps. So let's say I want to go 2 steps. These are the directions, and I do not want last only. So those are the places I can get to, and then, ooh, here's a chance to use my range thing that I was playing around with last week. So let's do range of 2 row of these references. 3 is sequence row. So that times 1,000,000 plus range of 2 call of, oops, sorry, not your 2 call, my 2 call. It is confusing to give to call the same name as a native function, but I am sufficiently clear on that. Don't use it with that name unless you are also sufficiently clear on that, would be my thought. So these are, yes, those are all the offsets that you can get to, and then I want to say is number X match this against this. Sorry, let's do minus minus, and let's do format comma. That looks good. Let's just see if I went only, sorry, I already did 2. If I did 1, yes. If I did 0, obviously it's just that. Oh, actually, interesting. Well, anyway, I'm never going to do step 0 because step 0 is just the number 0. So let's go back to steps 2, and let's say I want only the last step. Cool. All right, I think that works. Happy. All right. 15 minutes. All right. Unsplit it next. So the core of the idea here, like I said, is just to be able to do an operation on this row that doesn't require another call to map or by call or something like that. And so in a happier world where we could just say, text split this whole column by comma space and get something useful out of it, then lots we could do there, but we don't live in that world. But my thought was, so there's a workaround for text split, which is you can, first join them, like join all your strings with a different delimiter and then split on the delimiter that exists in those strings and on the other delimiter, and it gets you effectively the same as a 2D text split. I generally try to avoid that because your biggest joined string can't be more than something like 32,000 characters. And so, if you ever try to apply that to, a big table that might have 1,000 rows or something like that, it's very easy to go over the limit. But in the context of Unsplit, I think I would be fairly confident that one row of a table, even with an embedded list in it, will not go over 32,000 characters. So what can we do? We can say text join with, let's say, a pipe of all this. Good. Then we can text split that by comma space and by pipe. And that gives us that. So you can see we got R and then a bunch of NAs. We've got this because it has a whole list, M and just a bunch of NAs and that. That's also not the right way around. That's just the way text split goes. So we're going to transpose that. And now, so this is messy, so you could operate by row or you could expand or something, but my thought was we could say if is error, if the second row is an error, then give me the first row, otherwise give me the whole thing. And that will naturally fill it down with some broadcast trickery. So that's basically it. These two put together is pretty much the row operation. So I'm just going to say let call it SPL for split. SPLT, I guess, would make it more clear that I'm talking about split. Then we're going to say, well, first, just in case there's ever an entry with only one thing in the list, I'm going to say if rows of SPLT equals 1, then just return SPLT. Otherwise, I'm going to say if is error index SPLT row number 2 column 0, in other words all columns. If that's an error, then index SPLT row 1 column 0, otherwise SPLT. Ta-da! Then basically it. So I want to say lambda row, all this stuff applied to the row, and then I just want to apply that by row to the whole table. And that spills out nicely. So a couple of quick things to test. One is if there's just a data integrity issue, we'll probably end up with, yes, we'll end up with an NA here, but not here. I'm not planning on dealing with that because the kinds of situations I would see myself applying this in, this should just either work or not. So that's one thing to check. Then let's shorten this one also, and then it should go back to behaving good. Then let's just see if it works where I have an entry with only one. Is that it? K, wait, oh, sorry, that's the XK row. Here it is. Yes, that is working. And then the last thing is, because I'm putting everything through a text step, anything that ends up as that starts off as a number is going to end up as a number as text, which is not ideal. So I think I'm going to say let I'll call it raw, be all that stuff, and then I want if error 1 times raw, then raw. Happy days. Okay, so what are the inputs? So my first input is going to be just this, which I'll get rid of all these and just label this, I guess, table. Then my second input is going to be a delimiter. So in this case, comma space, delim. And then by default, I'm going to use the pipe here, but occasionally you might get data that contains a pipe or is delimited by a pipe or something. So what I want to have is an optional, I'll call it delim2, so that if you need to, you can say, wait, don't use pipe as the second delimiter, use this other thing. I thought about more general versions of this where, like, these might be delimited by separate things, or where, you want to delimit one by comma space, but you want to do another one by text length, kind of like the formula bar and grill. But I think for now, at least, I'm going to keep this simple. So we'll leave it at that. Okay, so that is referencing the table. That's good. This should now point to here. This is a little more complicated. I'll come back to that. I'll leave it as a pipe for now. That's it? Yeah, okay, I think that's it. So then call it unsplit. No, that is not an input. So then let's generate lambda statement. So we got table, delim, wait, what? Unsplit? Huh? Oh, sorry, steps, yes. Oh, did I say generate let statement? Sorry, I think I might have hit the wrong command. I did. So let's generate lambda statement. There we go. Table, delim, yes. Happy days. But then I want to add optional delim2, and then I want to say let delim2 be if omitted delim2, then pipe. And then I just want to use delim2 instead of pipe. I think we're good. Okay, so then we will save lambda as, we'll call it unsplit, and inspired by, Juan Jose Cifuentes. Okay, so then let's just say if I find and replace comma with pipe, that, yep, goes totally bonkers. So then I can say, I want to call this on a primary delimiter of pipe space and a secondary delimiter of, I don't know, $, and it's back to behaving. Cool. That is what I wanted. Oh my gosh, has Bo made this even simpler? I think he has. Let's see, lambda array by row. All right, let's just put it in here. So it's just an array, okay. Okay, so let's give it the array. It looks like it's set up for comma, so I'll change the delimiters back to commas. Oh, yeah, my version of Biro has an underscore. Okay, and then let's change the pipes back to commas. And okay. If 1, 0, then add plus x. Okay, so take X. Got it. So this is, I guess this version is designed to work on just a two-column version, if I'm reading it right. So if I do this, nice. So you split, so you repeat the label. That's very cool. Um, that's very cool. And a lot shorter than mine. Nice. Okay. All right, so that is shell and ball. That is unsplivet. Ooh. Okay, I've got enough time. I'm slightly nervous about doing these ones live because I haven't given them a great deal of thought. But what the heck? What the heck? So let's just have we're gonna have start one, end one, start two, and end two. And let's just fill in some random data. So I don't know, this one goes from 2 to 4, this one goes from 15 to 17, this one goes from 11 to 16. I guess, yeah, let's have some overlap here. The first thing I think I want to do is a union that will kind of collapse all these down. So I guess for that I don't even need the second one. Hum, 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 hum. And then, well, and then we'll figure out what else. But how is this going to work? So obviously the first step is just to take, let's just put in a few more data points here. So let's do, I don't know, 17 to 20, that'll overlap as well. Let's do 6 to 8, that won't. All right, so let's just think logic first and then we'll think about implementation. So the first thing would be the first range is going to start from there. And then where's it going to end? Well, you can look up what 2 connects to, and then you can see, I think it's going to have to be recursive to go through and say, okay, so now I have a range that goes from 2 to 4. Has anything started by 4? And if it has, then I'll go to the end of that. Now I have a new end of my range. Has anything started by then? And if so, and so on. Okay, this is not going to be easy. Okay, so I guess the first thing, I'm just going to sort these now, and then later we can assume that I will make sorting be a step in the thing. So, all right, so I mean 2 is fine. So let's just start with 11. So I want to say, and I guess the idea should be by the time, like we'll start processing here, we'll remove anything that is entirely covered. So by the time I get to here, I should only be starting from this. I think that's fine. So first thing we're going to do is XLOOKUP this in here, returning from here. So that gives me 16. Then the idea would be to say, well, this has started by the end of 16, so now we're going to pick up 17. So I guess what we'll say is filter this where this. Hey, Lorenzo. John, that's pretty much exactly how I feel when I watch Bo do stuff too, so I can relate. All right, so we're going to filter the ends where the start is less than or equal to that. That includes the, oh, sorry, the end times. So yes, that includes the 2 from before. That I have to think about. Well, I guess let's say that, and the start has to be greater than, just greater than? Yeah, just greater than is good. That gives me 17. Then I want to say if not found, give me this. And then I want to say max of that. So that gets me to there. So now I've got an 11 to 17, and then I apply, oops, sorry, I didn't lock. Filter this, where this, and this. So then so then I apply the same logic there, and now I'm going to 20, and then I apply the same logic again, and I'm still at 20, and then I say, okay, stop, because I've exhausted this. How worried you need to be lambda-wise? Honestly, I don't know. I don't know, because it's very possible that I'll write a bunch of, theoretically very clever lambdas, then tie myself in knots, forget how they work. Life is full of trade-offs. Anyway, okay, so from a given starting point, I can iterate this until I get to the final endpoint. Then I grab all of that, and then I want to know which of these are no longer relevant. And I guess the answer is anything that is up to that end time, because if I'm going through the start times one by one, so I'll go through, I'll say 2 to 4, I'll say 6 to 8, I'll say 11 to 20. And that will remove all of these. Yeah, I think that's the right idea. So now I have to write a recursive function. So, sorry, wait, I want to keep those. Those look useful. Wait, Bo, have you solved this already? All right, I'm gonna keep doing my thing for now. But then there's probably a much neater solution that I'm gonna see here. All right, so I guess I want a function of start and end, and I guess SD call and end call, and I guess and a recursive call. Then we're going to say let new end be all of this stuff. So we're going to max filter of end call, where start call is less than or equal to my old end, and where start call is greater than my old start, and if not found, give me my old end. And then we're going to say if new end, and why is this not auto-completing? It's slightly worrying, but maybe it's because of that. No, I've learned to take this as a serious sign that something is wrong. Yeah, it looks like I'm missing a closing bracket. But is that the right place for it? Yes, max filter. Good. Okay. So if new end is equal to end, then I want to return end. Otherwise, I want to return rec of rec st new end st call end call. Yes. So then let I don't know, find next end be all that madness. Then I want to say find next end of find next end, and wait, what? I think it's okay, of let's say 11, 16, this, and this. And hopefully that will say 20. And it does. Hooray. Okay. Ashley, good life decisions. Okay. So I think we're now going to say reduce starting from blank through yeah, let's say through sequence rows of this lambda a b. Then we're going to vstack a with and I guess maybe this should be like that, just to be safe. So vstack a with, yikes. So we're going to say if index of this by v. So if it's a start range that I'm interested in, by which I mean if that is greater than the max of a, I think I can do that. This is the kind of thing that Bo just knows, and I do not just know. So let's just whatever. 1. So if I say max of, that gives 0. Good. Okay. Shit. So say, let's say, or at A equals that, or index that is greater than that. And then let's just check that. So if I say blank minus 1 and max of that, I think it's going to ignore, but I'm not totally sure of that. Yes, good. Okay, so then my concern here is basically if I have negative values in this table, is that going to behave? And it looks like the answer is it is. So, okay. So we're going to vstack A with, actually, sorry, this whole if should come out. So we're going to say if A is blank or that, then we're going to vstack A with some stuff. Otherwise, we're going to return A. Because if this condition fails, it means, like here, for example, I've come to 15, but I've already got a range that goes from 11 to 20, so I'm not interested. Okay, this formula is growing and growing, and I haven't read it yet, but I'm just conscious that Bo's formula is a lot shorter than this. Anyway, okay. So what am I doing? Oh yeah. So now I need to bring in, so just put 1 for a second. NA is not good. Sequence rows of that. Index that's going to, not sure why that would be returning an NA, but anyway. All right, so now I need to go grab this whole madness. So max ignores text, but max A would not. Huh. Good to know. I think at some point I did know that, but anyway. All right, so let's let find next end be all that madness. Then we're going to reduce. Okay, so then we come to here. I'm still concerned as to why it's saying this is an error, but let's just say 1 and 1. That should really not be. Okay, there we go. All right, so it expands. That's good. We're not giving just errors anymore. Oh, right, I know. I was v-stacking something with only 1 column, and so when I v-stacked, I got like that. V-stack with 1 would have an NA in it, so then I take the max of that, and that probably gave an error, and that's why I wasn't happy. Okay, fine. All right, so then I'm going to vstack A with hstack index this by v with find next end of go away, I'm not done yet. Probably missing closing bracket there. Find next end. So what's the order here? The start, which is this. Might have been better off to give that a variable name, but never mind. Then same thing for B. That's the end. Then the okay, fine. No, why? This is offering me completion for hstack, but we're inside find next end. Oh, I guess it's just fine. Whatever. So start call and end call. Okay, is this gonna work? I don't know. Not obviously feeling super confident in it, but okay. So this part worked, but this part didn't. Why not? So, oh, sorry, yeah. So this shouldn't be at because I was checking is the first element a blank string. What I should really have checked is take a minus 1 and put an at on that. Hooray! Beautiful. Then we'll drop that 1 row. Whew. Okay. That worked. So now I think I have a working union. So I'm gonna, what do I want to call this? I don't know. Well, first let's generate lambda statement because I want to look at the bits. So I have start 1 and end 1. Yeah, no, I'm just gonna start. Let's call it start. Let's just call it start. That's fine. And then rename this to end. Okay, so then, no, now I'm repeating variable names in here. That's not good. Rename, so start, I've also used start call in there. Um, I don't know, start vowels. Why not? Although, realizing now, is that going to cause it to do a find replace in here? I might need to start again. Don't remember. Don't remember, I don't know. Nope, that worked. Gosh, this thing is clever. Okay, then rename this to end vowels. Say okay. That seems to be behaving. Then I'm going to save lambda as. Of your lambda parameter setup, is it also included in OA robot? Yes. I'm not totally sure what you mean by the question, but I think everything I'm doing here is very much included in OA robot. Okay. Sorry. Lambda name, I'm going to call it. I want to refer to range, but I also just made a range lambda last week. I'll call it RNG union. Okay. And then if we were to add in here a, I don't know, something that went from 4 to 6 and expand, that will do that. Happy days. And if we said this one doesn't go from 6, it goes from 7, happy days. Except that you probably, now I'm wondering why this works. Oh, sorry, yeah, it works because of that. So let's say I take the 7, 8 and put it down there, and the 4, 6 and put it here. Yeah, now it's not working because it does this one first. So we do have to sort. Okay, so edit lambda. So then we're going to say, and this is the handy thing where let will let you just replace things. So let start vowels be sort start vowels and end vowels be sort by end vowels by start vowels, which I think will by default be in the right order. We'll soon find out. 7 to 20. No, 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 no. Okay, let's, my sort by knowledge failing me. Sort this by this. And sort this. 4 to 6, 7 to 8. It should not go on to 20. That's not good. Okay, what's going on here? First of all, we don't have any cell references. Nope. Interesting. Okay, just show me. Oh, I didn't give the last step a name, which is bad practice. So call it result. That's all that, and then let's say hstack start vowels and end vowels. Oh, there are two variables named end vowels, which could be right. That's no, that's just because I re-alias them with let. So why isn't it working then? Forever after, all the references to them are, yeah. So then when I call it, by next, I call it on start vowels and end vowels, which have been re-aliased. Confused by that, so let's try just a find next end call here. With oh, wait a second, Ooh, this is not right. This is not right. This is not the same thing. What? What? Okay. I thought I could re-alias like this, but maybe I can't. Just to be safe, let's search for vowels, replace with vowels, use. That'll replace it in too many places, but that's okay. Then get rid of this, get rid of this, get rid of the, no, of course, it's because I was sorting on the version of start vowels that I had already resorted. That's the problem. Okay, so re-aliasing is very clever, but you do also need to be bloody careful with it. Lesson learned. Let's see if my result is happy again. It is good. Save lambda. Whew. Okay. All right. So, oh my gosh, Bo has come up with 3 different formulas in the time that I've been screwing around with this. All right, what do we got here? So let's, okay, start end is just 1. That makes sense. So we're going to scan, sort that max. Yes, that makes sense. I'm going to take the first column, take the last column, minus, oh, interesting, okay. Scan, start, and max. All right, let's name this out. Wait, sorry, where are we? Okay, so let's name this out. And then let's do SS. Huh. That is already very clever. Okay, so then S is just taking the first column of that, and it's just taking the last column of that, and the differences, fine. Then I is sequence max of n, 1, 2, 3, 5, okay. Oh, look at that. Look at that. It's so much cleaner than mine. Yeah, so we're saying if the duration is greater than or equal to I, right, sequence of max. So if the duration is greater, so in other words, longest duration, so we've got 2, wait, no, I'm confused. Give me back I for a second. Yeah, sorry, that is it. Okay, then we get S minus 1 plus I. Okay. So then the output is, got it. So these are all the values. That makes sense. I guess non-inclusive, it stops at 19. Okay. Then we're upgrading. This already feels like the basis of a much cleverer solution than what I did. So let's do the next one. Point it to here. And it's n greater than or equal to I, S plus I. And then what's this one doing? Grab that one as well. Oh. How? Unique to call. Oh my God, it's so beautiful. This is, oh, okay. I have to take a minute to explain this because it is just a work of genius. So, okay, we start off by sorting the thing, then scan max. So let's just hang on, tidy up a little here. And put so here's the sorted range, and then the scan max of that. So here where they don't overlap, it doesn't make any difference. But here where they do, so this 11 to 16, this now starts at 16. And obviously if this, if instead of being 16, wherever I go back and change, if this was, I don't know, 18, then that would kind of squeeze this down into just being one thing. Oh, this is so... Anyway, sorry. So that's 11, 16, 16, 17. And then we're taking the unique values that occur in this exactly one time. So if this ending smashes into this start time, then we get rid of these two. This one doesn't, so that we go from 2 to 6, we go from 7 to 8, we go from 11. Those two 16s cancel each other out, those two 17s cancel each other out, and they still would if there was, if there was a like when I made this bigger and this was 18, this 18, 18, 18, 18 would all cancel out. That is beautiful. So you two call that, and you get that. You take the unique values of that occur only one time, and then you wrap it up again. That is just delightful. That's so good. You did. Bo has done this on Advent of Code. That makes sense because this is the kind of question that they ask. I love that. Look at, just where's what I wrote? Come on, this is ridiculous. This is the difference between, you know, technically proficient, smash it on the head until it breaks, and just pure elegance. I love it. Oh, that's so good. All right, so guess I'm just gonna shamelessly steal this now. Oh, wow. Ba-ba-ba-bum. Okay, so cancel lambda edit. Nope, that one. Take this name and save lambda as. That replace yes. Oh, so good. Okay, and then this one doesn't work anymore because you have to point to them as one, but that makes total sense. Oh, wow. Okay. Amazing. Now I'm like, oh my God, do I wanna keep going here, knowing that there might be some. Anyway, let's be brave and let's try something. All right, so now I've got the union working. What I also want to be able to do is I want to be able to do the intersection, and I want to be able to do the difference. And for this, let's assume for now that I will just have unioned anything that comes in. So we'll put that there. We'll get rid of all this. So let's say that I only have non-intersecting ranges here, and oh, that's what? Oh, right, yeah, because it's not working with blanks, but that's fine. All right, so I don't know. Let's say I have 5 to 7. Let's say I have I don't know 9 to 12, and let's say that I have one that's entirely contained would be particularly tricky. So let's say I have 18 to 19. Okay. So I think inspired by Bo, the first thing I'm going to do is sort vstack this with this. I guess I can just say that. So then all my possible start and end times are here. So what do I want to do? I want, well, yeah, so the scan max idea is still a good one. So a scan, scan comma this max. So, no, actually, do I? I don't want a scan max because I want a range starting from 18. So I want a range starting from 2. Actually, sorry. No, I don't want. Right. So just first of all, just purely manually. So 2 to 6 becomes 2 to 5. 7 to 8, still 7 to 8. 11 to 20 becomes 12 to 18 and 19 to 20. So hang on, I shouldn't have got rid of my vstack. So let's sort vstack this with, actually no. My start times are going to be, my potential start times are going to be sort vstack of, so an interval will either start at a start here or at an end here. So I have something starting at 2, at 7. I don't have something starting at 11, but that's okay, at 12 and 19, and we can certainly unique that. So then the question is, how do I work out where I'm going? It's getting tricky. So from a start of 2. So I guess the logic is if it's a start of a range here, then I want to go until either the first of these or the first of these. Yeah, okay, so hang on. This is my starts. And then I also want my ends, which will be kind of the same thing, but oops. But I'm going to stack that and this. So 2 to 5, 7 to 8. How do I figure out which one of these are real? Maybe the answer is get rid of the unique first. Would that help? sorry, repoint those. Then they might line up better. So 2 to 5, yes. 7 to 6, no. 7 to 8, yes. 11 to 9, no. 12 to... This might just work. Is it just if this one is greater than... That looks good. If it's a logical order, then I think this might work. Okay, so do I still want my input in the form of start end if I'm going to be referring to different bits? I think I can handle that. So let's say, just call this SE_1, get rid of that, call this SE_2, get rid of that. I'm just going to separate these a little more just to make it, I don't know, robot is pretty smart, but try to make it obvious to robot. Oops, sorry, that these are separate things. Like I said, I think it'll figure that out anyway, but fine. So this is starts, this is ends, then we're going to say filter hstack starts and ends where ends is greater than starts. I think that's it. That's simpler than I expected. Okay, so then, sorry, this is the difference. Hang on, wait, I said I wanted union, intersection, and difference. Okay, good. Okay, cool. I think that worked. So let's generate lambda statement. So wait, what input to, what else does it think? Oh, interesting. All right, so let's not do that. Let's do this. Let's do this and just make this a constant. Cut that, put that there. And then let's do this. Okay, let's try that. Generate lambda statement. It's right there at the top already. I didn't need to type anything. Okay, start end 1, start end 2, yes. So we calculate starts, we calculate ends, we calculate result. That looks perfect. Okay. Save lambda as. I'm going to call this one RNG diff. And this one is an ordered operation, much like, subtraction. 5 minus 2 is not equal to 2 minus 5. So actually, just to test, let's see if I do RNG diff of this one minus this one, what does that give me? So it cuts off the start of this one, so you go 6 to 7. It cuts off the end of this one, so that only goes up to 11, and it cuts this one out completely. Cool. Someone says, I'm new to Excel, trying to learn more and more. I still feel so humbled when watching stuff like this. Thank you for doing it. Trust me, that is, there's a lot of there's a lot of humbling going around in this community. There's some amazing stuff out there. So I do a certain amount of humbling of others, and I do a certain amount of being humbled myself. I've done a bit of both on this same stream. Okay, so that's working. Now what I want is the union. And for that one, I think, sorry, not the union. Wait, what? The intersection. I need a Venn diagram here. So let's insert. Literally going to draw a Venn diagram. So here's my Venn diagram. And I guess I could make that a little, no, fine, whatever. None. And I just format paint this, maybe. Format painter on that. Boop. Oh, what? Shape fill, no fill. There we go. Okay, so I've got the union, which is all three of these. I've got the difference, which is that one. This is what I'm looking for, the intersection. So what does that look like? It looks like 6 to 7. There's nothing that intersects with 7 to 8, 9 to 11. So it looks like 11 to 12, and it looks like 18 to 19. So this is probably still a function of my starts and ends. So let's see, 6 to 7, it's that. It's, no, there's no 11 to 12. Okay. Right, because I don't have the right set of starts, do I? So I want my starts to be all the starts, and I want my ends to be all the ends. 2 to 6, 5 to 7, but that's not enough by itself. What is... having seen Bo's amazing union and having worked out a difference that I'm quite happy with, I'm confident that there is a similar neat approach that will give rise to the intersection, but I can't immediately think of it. So let's see. Hmm. Guess you're never gonna have the first start. And you're never gonna have the last end. So what if I drop that by 1, and what if I drop that by -1? Does that look some 5 and 6 are there together? 11 and 12 are there together, and 18 and 19 are there together. Could it be so simple? So then filter H stack this and this, where this is greater than this. Ooh, do I want it greater than or equal to? I'm not sure. That's an interesting question. Do I want... I could see a situation where I would want to know that 7 is an overlap, or a situation where I could not want to know that. So maybe we can take both. Is it this simple, though? I wonder if I've just come up with an example that's too basic. What if I made that a 10? Oh, sorry, yeah, this is a constant. Let's go up here and make it a 10. I don't know. Need some more data sets to test on, I guess, but yeah, this isn't diff anymore, this is int. I guess the other thing is, would it still work if these were not the same size? So let's try adding, I don't know, let's say 19.5 to 20.5, just for a laugh. Does this still look, oh, sorry, yeah, gotta expand. Boom, gotta expand. Boom. So we got 5 to 6, we got 7 to 7, we got 11 to 12, we got 18 to 19, we got 19.5 to 20. That, I mean, it does look right. I'm just not I guess the other thing is, are we alternating here? Yes, we're going 2, 5, 7, 10, 11. What if it was not as neat as that? What if this was 5.5? Sorry, change it here. 5.5, would it behave then? 5.5 to 6, 7 to 7, 11 to 12. All right. I still have some work to do to satisfy myself that this is in fact, like, these random tests are not a proof, but I'm getting more confident that this might be the right approach. So for now, I'm going to save it because we're at the hour anyway. So let's generate lambda statement, se1, se2, start and end results. Okay, save lambda as, that's going to be rng int. Okay, now Bo has something here. Let's see. And oh my god, look how short it is. This is ridiculous. Okay, so let se be sort pointed to here. That hash is scan that and take the filter that. What is? Not sure what this one is trying to do. If sb scan se max and we take that minus that. Right. Filter take se1. Why is it? Oh, because there's. Oh, sorry. Yeah. Because this is a range that doesn't. So fine. Let's have this one go from. Sorry. Let's have this go 2 to 6 again, and let's have this one go from 5 to 8. There we go. 5 to 6, but not. Um, I guess this is trying to just operate on this, on one combined thing. And does that work? I guess yes, if I've made these distinct first, then the combined thing. I guess the other test would be I can do RNG union of this and this, and then I can do RNG diff of that and either of these. Oh, we didn't like that. Oh, sorry, of VStack, because this only takes one argument. My bad. Oh, I didn't like that anyway. Bother. What? 210, 25. What? Wait, have I already got a sort in here? I can't remember. Let's try sort. Let's see if that helps. Does not help. Why not? Okay. Edit lambda. So show me SS. 266888. That looks good. Okay, then. So the issue is that we're not getting the right. Yeah, we should be getting. We got 2 to 6, 6 to 8. It's the 8 to 8 that's killing it, isn't it? So why is there an 8 to 8? Because these two become the same when you max them, I guess. Okay, what if I say sort this by 1, then 2, ascending, then descending? Would that make it happier? No. No, oh, sorry, ascending, then descending. That still has the same problem, doesn't it? That's a puzzle. So yeah, so I guess what I need is to keep the things that have an odd count. So I could, what if I said most of SS? And then I filter, this is called it CNTS for counts, and then if I filter, take CNTS first column, where take CNTS last column is odd. And then sort and wrap. Wrap rows. So that's sort wrap in 2s. 10 to 20.5. So we got 10 to 12, overlaps that, overlaps that. Yeah, that looks good. Rather than doing generate lambda followed by save lambda as, you can just do save lambda. I knew that once upon a time, and then I forgot it again. Thank you for the reminder. Okay, so I've made this a little more complicated, but I think potentially also a little bit more robust. So okay, that's good. So let's save lambda. I mean, I need to test these a bunch later, but for now, okay, so then I don't think I need the sort anymore. That's good. So then let's try an RNG diff of that versus, it should be the same answer with either of them, I think. No. What? Not even close. What? We should be subtracting off from, oh, sorry. You know, we are. My bad, my bad. So we got 2 to 8, 10 to 25, but now we get 20.5. Okay, yes, that worked. And if I do the same thing, but subtract off the second range instead, that gives me a completely different answer. What? Why? So let's just get this back out. So is my diff doing what it's supposed to then? If I take the union and I take away one of them, Oh, no, that is the symmetric difference. That is not the intersection at all. Okay, never mind. I'm being a moron. I'm tying myself even further in knots, so that should not work or do anything. It's confusing. All right, so do I have something that is basically working now? And if I do, then I think it's time to cut my losses and stop. So first I want RNG union of the stack of this with this. Yes, no, you put in a stupid star. That's working. RNG diff. Ooh, we didn't, oh, sorry, no, get rid of the v stack because now we have two arguments. So we get 2 to 5, 5 to 6. No, 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 damn. Okay, well, I guess if I then said RNG union on that, so I get 2, no, no, why is 5 to 6 in there at all? It shouldn't be. Ah, right, because it's in here twice. Okay, so I should be first applying union to each of these if I'm not confident that they're just joined. So then I get 2 to 5. Yes, because then this cuts you off. 5 to 8 becomes cut off to 7 to 8. Yes. 11 to 20, you get 12 to 18 and 19 to 19.5. Yes. Okay. I don't think I'm going to be ever applying these on particularly big sets, so I think I will just edit lambda and put in the range union here. So let SE underscore 1 be RNG union of SE underscore 1, and the same thing for 2, and then carry on. And then we can get rid of this, and this, and this, and this. Okay. And I guess for the intersection, I should be doing the same thing. Yeah, because this is going 5 to 6, 5 to 7. That's no good. It's total nonsense. So we'll add lambda again. And we'll add in the exact same first step here. Let SE1 be, what did I say? RNG union of SE1. And the same thing for SE2. Okay. Bo says union fixed. All right. Let's see what we got. So we'll come here. So where are we pointing? We're pointing. Let's do them both, I guess. V stack of this and actually no, sorry, yeah, just that one already has some overlaps, I think, so we're good there. 2668. Sorry, oh, that's out. So let's do SS 2668. Yes. So hang on, wait. What does my current one do? Union, range union. This, does it get it down to 2? It does. Okay. So, where are we? SS, filter SS where the difference is not 0. Got it. So that's all of them for now. W is, what? No. It doesn't, why would that? Okay. 8, yeah. Oh, sorry, it's missing a, oh, do with both A27 and D27. Okay. So V stack this guy and this guy. 8, 10, 12, 12, 20, 20, 20.5. Seems like it's become more verbose because it's not merging these and it's not merging these. Do, 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 do. So what's going on here? FL. Yes, and then we filter where it's a non-zero. Is there a 2-col missing here? It might be. Oh, there we go, yeah. And out is filter SS. Wait, what? Oh. Sorry, so I'm returning W, but then I'm going to return out. Filter SS. Hang on. Wait. I'm going to screw this up. Let's grab this again. So yeah, it looks like the W step and the FL step are not actually getting used in the output. I think something is not right here. But the W step looks good. So the thing that was causing the problem before was something occurring an odd number of times. So when 1, 2, 2, yes. So now you're getting rid of the 2, 2. Yeah. Okay. That is a sensible fix and simpler than mine. All right. So let's go back to my RNG union one more time. Edit lambda. So SS is that. So then we take filter and W and bring them in here and return W. I think. Let's give it something. Okay, I think I like that better. Okay, so then save lambda, and let's just bow. Cool. All right. I think that's all I have time for this week. So let's see. What do we got to look forward to next week? Done those. Line of sight is kind of simple. Done that. This one is a good one. These ones are a little bit complicated. I don't know. We'll see what we get to. I feel like I keep dangling the kind of big complicated algorithms that might be fun, and then doing quite quotidian stuff instead. But anyway, that is all I have time for today. These, plus probably 10 other things that I think of between now and then, are next on the list for next week. Thank you for coming along, and see you next time. End stream. Yes, end stream. Which hopefully did in fact end the stream.